Okay, good evening, everyone. I'm happy to see you all at our evening podcast, BA Day Afterwork Talks. It's our 14th episode, and I have great guest with me, uh, Thomas. We will come to him a little bit later. Let me now just remind you who we are and yeah, what is it all about. So usually we have two hosts. We have Rainer with us. He's a founder of BA European BA Day and also managing director in Masventa. He's seasoned expert in business analysis and also certified in different types of certification of business analysis. I'm Alexander Moskalyuk. I have more than 20 years experience in IT, and also I have certified business analyst in different branches, and I have experience in business analysis, project management, in development, and cybersecurity in different domains. Together with Rainer, we are looking for really interesting experts with real life expertise and trying to bring them to our podcast just to share our information, just to share with you uh, and real life knowledge and practical experience about how we can use business analysis in different domains, different projects, in different situations. But before we go on with our tonight's topic, I want to remind you about our sponsors. Thank you to Deutsche Telekom for sponsoring and supporting our conference and our podcast. They are our main sponsors and the best one. Also, we
Of
have
course.
sure it can be different. Yeah. Anyway, yeah, really, thank you very much. Thomas represents Deutsche Telekom at our conference. He will be keynote speaker and also he's expert in business analysis. And as other sponsors, we have consulting companies IBO, IRAB, and Masventa. So thanks to all of our sponsors. Please visit their booths during the conference. But now let me switch to our tonight's topic. And Thomas, I know before you can tell you a few words about yourself, I know that you are the Deutsche Telekom is now rolling out the huge project of connecting a lot of households with fiber. And take into account that it's they want to do it in I think short terms, so it's a really complicated task. And tonight we will talk about this and how business analysis and business analysis professionals can help companies in such projects. And we will hear some little bit insights from Thomas here about how is it going. But before, Thomas, please tell you a few words about yourself.
Yeah, at first, thank you, Alexander, for having me here tonight. It's a pleasure to talk to you. So as we just had a chat earlier onwards, as you all know, Deutsche Telekom is almost unknown, but T-Mobile is known by almost everyone.
Yeah, it was.
So
I am really sorry. I could not connect all these two names
yeah,
in my
yeah.
head. Yeah, till tonight.
So indeed, Deutsche Telekom is quite a large company. So we have about 261 million broadband customers, so mobile customers. We have about 200,000 employees worldwide and have a revenue of about 125 billion euros per year, if I'm not mistaken. And I'm a small gear in the big wheel of Deutsche Telekom. I'm working as domain architect and solution designer, which fits perfectly to our business analyst day because actually what we call business analyst at Deutsche Telekom is the guy or the girl who knows everything about the business, who understands the customer, knows what the customer wants, sometimes even better than the customer,
Yeah,
and is able
sometimes even
to
help them. Yeah, is this.
exactly, and is also able to explain it to the developers, to the testers, to the operation guys, like, hey, what do they really want? What needs to be done? So as you can see on the picture, it's a bit photoshopped. I removed all the wrinkles, which I already have. So I'm working now since more than 25 years in the IT business. In my first years, I was working in supply chain management, so totally different area than telecommunications. So I did the automation of supply chains with just-in-time, just-in-sequence delivery for IBM at this time, IBM Global, and later on then in Southeast Asia for contract manufacturers. So for companies like Foxconn, for Agile, for Omron. So for all those companies who have a lot of material input, who needs this material input at a certain time to manufacture great output. And this was 25 years back. So there weren't so many commercial off-the-shelf solution available for this. So at this time, we were using MDocs or Rosetta Net to talk to each other. Since we connected SAP and Mapic system or I2 system to Excel sheets of small suppliers or to other manufacturing and shop floor control systems. And from this time onwards, I was doing design. So I started off in my young years as low-level code designer. So basically, when the business analyst already was talking to the customer, knew what to do, then he gave it to me. And then I decided, okay, how do we solve this with the current technology, with the libraries, with enterprise Java beans, which was the latest hottest thing as this time. Now it's already old. And then out of coincidence, I came to telecommunication, so to Deutsche Telekom at this time. And Alexander, as you were asking me before this talk, yes, we are still operating a fixed network.
I know that even you use fax machines.
Yeah. That's so true. Yeah. And at this time, we had an old mainframe from IBM, where the software was written in COBOL, where our copper-based fixed-net was managed in. And at this time, so 2005, ADSL was introduced in Germany, but it was also foreseeable that VDSL, VDSL2, VDSL vectoring is coming up. And everyone said, okay, this mainframe is out of maintenance soon. We need something to replace this. So I was working in a kind of a big project where we were working on replacing this mainframe, which was managing the copper-based network with a bespoke new development. So with basically a Java-based, component-based microarchitecture with integrated bus communication system, which was easily extendable, because this was also a thing which I learned at this time. I always thought if you build a network once, it will last until 30 years and then you'll do a new network. But surprise, surprise, the network is changing every day with a lot of changing rates, like hardware is getting repaired, replaced, upgraded, aggregated further. And so the so-called fixed network is always in move. So it's always being changed and worked on. So for quite a while, so about 8 years, I was working in this mainframe replacement where we replaced this function of the mainframe with a new function, but not just replacing it, but enhancing it further so that with almost zero touch, we could accept orders from the customer, process them, build new network, and send out our installation guys, our blue collar guys outside to basically install the customer service. Yeah, the network changed. I was working a while in the aggregation layer network. So in everything which is IP backbone, where we removed old label edge routers and label switch routers with broadband network gateways, simplified the configuration, simplified the billing, simplified assurance and the provisioning for software projects. And actually in 2008, Deutsche Telekom was starting to roll out glass fiber. And at this time, you can imagine it was like in your local town, there was a spreadsheet. And if you were interested in fiber, you could go to the telecom shop and say, hey, I'm interested in fiber. So they noted your name down in the spreadsheet. And when the spreadsheet had enough entries, then they said, okay, maybe we roll out in your town. Then we rolled out the fiber, digged everywhere, put tubes into the ground, connected the houses, then documented everything in our IT system. And when everything was documented and working, then you could go to the shop again and order a product. We did this for 10 years and then found out, shit, no one is buying our fiber products. Why is it this way? Well, the process is much too complicated. So no customer these days goes to a shop, registers for a spreadsheet, then waits 5 years to get digging in front of his house and then signs up for a product. So what I want to show you today is basically the current challenge. How do we speed up the glass fiber rollout in Germany? How do we turn this process around to make basically it happen that we can roll out a vast amount of glass fibers in much, much shorter time?
Yeah, and did you really start rolling out fiber in 2008? Because I thought
Yes,
it's more or less modern technology, so it's too old for
it
now.
is. It is really that old. Actually, actually, when Germany got reunified in '89, even there a decision was made that in the eastern side of Germany, the infrastructure is getting renewed, and over there we were not rolling out copper fibers, but glass
Mhm.
fibers. So we use glass fibers for even for the public switched phone network. But at this time, the glass fibers that we used were not, how to say, capable for the bandwidth that we need today. So today we're using fibers that can carry up 6 gigabits per second, I guess.
Mhm.
And so everything which we already rolled out after German's reunification, we need to remove and replace with different kind of fibers. But yeah, actually this PON technology, so this passive optic network technology, we piloted in 2008 in a big
Wow.
city in Germany to see how it works,
Mhm.
how we can operate this, how stable it is for the customer. So is it the same stability as copper network, or is the internet shaky? Because as you know, as home office worker as me, there's nothing more bad than a non-stable internet connection, right?
Yes. Yeah, it drives me crazy
Yeah.
sometimes when I can't connect to something.
Yeah, so this was basically the first pilot, how to do this. And then we learned from this pilot and from the next 10 years, like what's the problem with digging? How can we dig in different scenarios, like if there's plaster, if there's tar, if there is green? Which technology do we use to put the fibers in the earth? So do we really dig, or can we just carve a tiny thing, or do we do trenches, fine line trenches? How deep
Mhm.
shall we dig? Then also we had some pilots in how do we provision service at this time? How many customers do we put on one line? At the moment, we're using a splitting ratio like one active component is serving 64 customers. And this is still having quite a decent bandwidth for each customer. And yeah, it was a time of learning because on the other hand, I mean, we didn't have this pressure because we also own the copper network, and we were selling VDSL vectoring with up to 250 Mbit. So it wasn't really that big pressure. I mean, if you want to use up 250 Mbit, you need to watch how many HD movies in parallel. So all of
Yeah,
your kids
actually,
can watch.
yeah. Actually, but in Ukraine, this pawn technology became really actual with these blackouts. Because when you
Mm,
have blackout, the pawn PON equipment still works, and you can have internet, while your notebook and modem is charged.
Yeah.
So yeah, I finally got my PON as well 2 months ago from our provider, and
Mm-hmm.
yeah, and but I think it's really it's great. It's modern technology, yeah, and I hope it will stay with us for a few years.
I hope so. Yeah.
Yeah, before it will be replaced with something else. But
Yeah.
anyway, yeah, as far as I understood, you had some pressure, yeah, from business stakeholders to start rolling out it quicker in scale it more and more, yeah.
Yeah, absolutely. So as I just said as a little joke, yeah, no customers waiting 5 years to from order a product to get a product, right? And also our competitors are not waiting. So it is at the moment to say it like this. Fiber is a hype. Everyone wants to have fiber because they see that our bandwidth is getting used more and more with all the streaming services, with more and more video conferencing at home, with more applications that use this high bandwidth. And it's basically an invest into the future that we do as Deutsche Telekom, that we say, if you own the network, then you can, how to say, serve customers for the next 30 years, 40 years with this network. If you don't own the network, but have to rent the network from some competitors, so then, yeah, your margin is much less, right? To say it
Yep.
as clear as this. Yeah,
And you can't provide any other additional services. Now you can put, you having the additional capacity in the network. You can add some IoT devices, you can provide some different tools, for your
yeah,
customers, and it's great business. Yeah,
that's
totally
true.
agree.
Yeah, yeah,
So what was the context? Yeah, what was the most complicated?
yeah. Talking about Deutsche Telekom, so it says already in the name for those who can understand German. Deutsche means German, so we are the German Telekom, and we are rolling out fiber in Germany, as well as in other European countries as well. Um, what's a bit different from Germany to other countries? I just was on vacation last year in Spain. And for instance, in Spain, rolling out fiber is easy because all the fibers are on wooden poles outside of the houses.
You have benches of them, yeah, hanging from.
So rolling out
Uh,
fiber is easy. In Germany, almost everywhere, except if you have a single house in a forest where the hunter's house is, you are enforced by the law to put it in the earth.
okay.
And so there is no put it on pole and serve it. And it's even as strict as after your work, it has to look the same way as before your work. So if you are in a
Okay.
historical downtown and you see, ooh, they have nice plaster with carved stones, you have to prepare it exactly like this. And basically, what you see on the left side is our whole customer journey. So everything starts with this beautiful cars that you see here. Those are not Google Street Maps cars.
Deutsche Telekom cars, yeah,
Those are
the
Deutsche
mobile cars.
Telekom cars, yeah. Deutsche Telekom fiber rollout cars. So we start to drive through towns that we plan to roll out. And at the end of this beautiful journey, you see happy customers serving on their couch with hopefully incredible bandwidth and stability like that. And if you look on the sheer numbers, in Germany, we have about 40 million households, roundabout, with 82 million inhabitants. And already right now, we are driving more than 2/3 of the fiber rollout volume, which is quite a significant
Huge.
number. And we aim to do even more. So we aim to construct 2.5 million households per year. And if you deduct this number down to how many sockets we have to install per day, we're coming round about 10,000 sockets that we have to install per day. Yeah,
it's huge.
it's huge. Yeah,
It's really huge.
yeah, it's really huge. And this is basically our unique challenge. I was attending a conference of the TM Forum, which is basically the group of all telecommunications companies in the world. And there was one company presenting like, oh, they rolled out fiber and oh, it was so complicated and such a big project and it lasts them so long and costs a lot of money. But now it's done and they rolled out and was asking them, why did you do it? And it was like some small town Slovakia or so with, let's say, 1 million households. And I was like, that's what we're doing in half a year.
and it looks after this just the same it was before, yeah. And
Exactly.
they have everything, yeah, on this
On the
wooden
pole, right?
poles, yeah. Yeah.
Exactly. So on this, on the sheer scale and on the sheer how to say, on the big numbers, it is easy to understand that we have to think about each tiny step, about automation, about how can we do this with help of IT and not with the help of human workforce. In the past, so in the pilot that we did 10 years back, we learned, okay, if you want to roll out fiber, you need planners. They really need to know how is the town looking like, where are the streets, where are trees, where are rivers, where can I dig, where it is forbidden to dig. And they planned really centimeter per centimeter where to dig, how expensive it is to dig. And yeah, we cannot do this anymore because we don't have so much planners, basically.
Yeah, 10,000 planners plus 10,000 workers, yeah, who will just install it. I think
Yeah,
your business customers won't be happy, yeah, after these numbers.
exactly. And this is why in a second we can have a look at the next slide. So we really need to have an IT strategy which is not compassing of, let's say, one IT product and one application, but we have many IT applications. Each one of those is designed and implemented in a different way to, at the end, have happy customers. And I showed it here in the slides in basically two ways. So on the top in magenta, you see what we call the area journey. So what do we do with an area? How do we know which area to roll out? How much it will cost to roll out this area? How much construction companies we need, right? How many workers we need? What plan we need? So you see here where your pointer is currently, it all starts with this T car, so our telecom car, which basically just drives around in this town, making LiDAR scans of the whole town, 360-degree pictures and high-resolution pictures of everything. Why? Because after this, no one needs to drive out anymore. We can do everything in the office and we can do anything with artificial intelligence later on.
Mm-hmm.
So this is where it all starts. And you can imagine, I don't know how many townships we have, but it's quite a lot. So we have a lot of those cars and those are driving in every town in Germany and scanning those towns. Then underneath this internal geo-information, of course, since Telekom is basically operating the copper-based network since World War II. And of course, we already have a certain geo information in our IT systems. So we are using Small World of General Electrics as our geo information system, where we exactly know all the map data combined with the data from the officials, like where is which river, bridge, concrete structure underneath, and so on and so on. And we also know where we already trenched, digged, put tubes, put any infrastructure from us inside. And if you have eagle eyes, Alexander, you see that the symbol shows an iron to iron clothes, right?
Yeah.
Basically, the problem that we had is most of our plans that we had are from the 50s and from the 60s. And in a
Okay.
project of the 80s, everything has been scanned.
Okay.
And the scanning wasn't so accurate in all situations. So sometimes the guy who scanned it put the map a bit, how to say, a
Yeah.
bit
Yeah. Not.
rotated,
Uh-huh.
or he moved it way too soon or
Mm-hmm.
so. So we found out that if you look at the coordinates in our maps and check then the real GPS coordinates, sometimes we have a difference of, let's say, 50 meters, which is bad if you want
It's
to dig, right?
yeah, and I think it's a lot. Yeah, if we're talking about city
Yeah,
or
yeah,
some
yeah,
town and buildings, it's everything.
exactly. So I come to this TCAR later. I just want to explain all those aspects here. So we have the new data with fancy new technology, with LiDAR scans, or with point clouds, with 360-degree pictures, with everything else. And we have the scanned information from good old paper scans with data from the last 50 years. We use this new fancy information to identify potential routes. This is what
Mm-hmm.
this pot means. Actually, this is our business case for using artificial intelligence. So we trained a AI, and I'm coming to this later on, to detect which path would be the cheapest path to dig based on
Mm-hmm.
certain criteria. Yeah. Then you see that the two gray lines come together. So the new information, which is scanned with recent scans, and the old information is combined to one harmonized information. And a human finally has a look into it and checks if this structural planning, like which houses do we connect to which street cabinet, and which street cabinet is connected to which central office, is finally determined and how to say approved in our systems. Now, if you see, there is a specific thing where your mouse is currently, location approvals.
Mm-hmm.
As you might know, I mentioned earlier, everything has to look afterwards like it looked before. So everywhere where we dig and everywhere where we place street cabinets, we have to get an approval from this, from the city council,
Mm-hmm.
from the mayor of the town, from the state council, and everything else. And guess how many approvals do we need just to place one street cabinet? How many papers we need to prepare?
Let me guess. I will go with 20.
It's Germany, Alexander. Come on.
Okay, 100.
Oh no, no, not that much. It's over 30. Over 30
Wow.
approvals. Like you have to certify that you don't harm with chemicals anything, that there is no water protection area, that no endangered animals are living there or breeding there. Then you have to ensure that you don't take too much space from the public space, so that any mom with her children can pass by, and so on and so on. And one of the most important things in Germany after World War II, you have to certify that there is no bomb in the soil,
Mm-hmm.
no bomb from Second World War,
Mm-hmm.
which sounds a bit strange, but indeed, in Germany, even after 80 years of World War, um, each year we have over 20,000 bombs which are still found. So everywhere where you dig, you are in danger that you hit something which you don't want to hit because it makes a big boom.
Yep.
Yeah,
Yeah.
and this is something which takes the most time, because you can imagine that for each and every location, you have to get approval, and for each way you want to dig, you also have to get approval, and you need to get all this paperwork done, right? So this is basically which is eating up the most of the time of our colleagues. But also there, we found a way to help them. So with the information that our TICA was scanning, they don't need to go outside. They basically have something like an augmented reality application where they can see the street in 360 degree, can place the street cabinet, can change it, can move it, can do the measurement, like how big is the distance, how to do it. And then with this augmented reality can create all the needed paperwork that is needed to get approval for this. Yeah.
I think
So
it saves a lot of time, yeah, just to prepare all these documents.
exactly, because when we didn't have this, we only had a paper plan. Then someone had to drive out with his car, had to look at it, make pictures of it, and so yeah.
All the designs, everything else, yeah.
Yeah, so this was a tremendous improvement that we did. And from a business analyst thingy, you can imagine, okay, already until this point, we have terabytes of data that is processed already by the scanning data that somehow needs to be managed in a certain way. And what I didn't mention so far is those friendly looking faces at the bottom here. May I introduce you to our customers? So Alexander, here are our customers. So of course, if a customer like this girl here places an order because she said, oh, I saw a telecom car in my town, let's order. We already want to accept this order. And of course, we want to tell her, thank you for your order. Yes, we are in your town, and most likely your house is being connected in 2 months, in 3 months, in 5 months. So already with this early data, we want to give our customers a horizon, like when they can expect their product in this case, yeah. So, but let's continue with the area journey. So after we did the structure plan and are working on getting approvals, and approvals take quite long, then we are doing the detail plan, like we in detail plan where to dig, how to dig, with which machines, with which method, where to use tubes, where to use tracks, where to use poles. As I mentioned, in the hunter's house in the forest, we can use a pole.
Yeah, it's a happy coincidence, yeah.
Happy coincidence, exactly. And then the next thing starts. So if you want to construct 10,000 sockets per day, of course, we don't have this big amount of field engineers. So we have to get construction companies who are doing this for us. So a big amount of our software is basically managing our suppliers. So the construction companies are our suppliers. So we have to exactly tell them where to dig, how to dig, when to get everything accepted, what they digged, and so on and so on. So this is the component that we call our supplier and partner management. So most of the things we build with our contract not manufacturers, but constructors. But of course, we also have partners, like in Germany, most of the towns have the so-called Stadtwerke, so the local utility providers, which are in most cases owned by the town itself. And they say, you don't dig in my town, I do the digging and for you, and then you get the network from us. So we have a lot of partners from this as well. And of course, what they do, we have to check so that they did it in the right way. This is the acceptance. And indeed here, we also came to the conclusion, well, we do so many construction work, it's basically impossible to do the acceptance of this work with everything that you can imagine with it. So with claims, with refunds, with price deduction, with rework, with all this which goes into this.
Yeah,
issues, construction issues. So, or we also have cases where construction companies just disappear. So they go.
Yeah, it happens. Yeah, in Kiev, for example, they can disappear when you just finished almost all the building. Yeah.
Yeah, exactly. So everything with this is handled also by an IT system, and even the acceptance is automated. So for the acceptance, we also use tiny portable LiDAR scanners where we scan whatever the did.
Build,
And
yeah.
with and with AI, then we check, is it deep enough? Is it with the right distance
All the
from the
rules.
street? Yeah, exactly. Then everything needs to document, because when you and me are 20 years older and enjoying our retirement, then our kids are doing this, and of course they want to know, hey, what did you do? Where are our cables?
Where we can find it, yeah.
Yeah, exactly. So we need to document it in our systems in a way that we find it even in 20 years and 30 years and so on. Yeah, and with all this area journey, you see the happy customers. So in Germany, most of the people are not owning the house, but are renting a flat in a house. So if this girl orders and this girl is the tenant only, then the next guy, the landlord, has to approve that we dig in his house or that we drill in his house. And so we have basically a customer-facing inbound order management system, which is surprisingly glasfaser.telekom.de. damn easy, where anyone can order a product, a fiber product. And in the order process, the customers ask, do you own the house? Or are you only renting the flat? And if you're only renting it, who's your landlord? Then we do all the negotiating with the landlord, do an exploration of the house. So we make an appointment there to check where to drill, how to drill. And finally, then our installation guy with a happy face is installing everything. And we have basically an instant activation. So as soon as the last screw is set and the device is plugged on, it's ready to use and the customer can serve, which is in total, I mean, it sounds now big, but from the first, when the car is driving out, to the customer is able to use the products is less than 6 months.
It's huge.
It's huge. And this for 10,000 sockets a day.
It's unimaginable. Let me say it this way.
Unimaginable, yeah.
Yeah, because actually, I think it's a great example how it looks like, yeah, really simple. Not sorry, not even simple on this small diagram, but actually
Yeah,
we see that yeah, to provide value, there is too many steps, and to provide it as customer expects, we need to do a lot of integrations, a lot of synchronizations, a lot of
that's true, yeah.
calculations. Yeah, and I think it's a really complicated project from technological and even from business analysis part, just to put all these
Yeah,
things together and define how should it work.
yeah.
So it's really huge.
And to say it honestly, if you go to the next page, let's say 3/4 a day, I'm doing solution design of designing the business requirements into solutions. And the other quarter is thinking about how to make it performant enough. Because whatever solution we do, we always have the scale challenge, as I call it. As you see here, Germany has 41.3 million private households and 3.8 million commercial sites. So this is basically our footprint. We want to roll out 2/3 of this with fiber, which equals to 10,000 sockets a day, which are to be installed. And to achieve this big number, this pipeline that you saw in the earlier slide has to constantly run up to a certain level. So we cannot do that. We do the T car in town A, town B, town C. It must all happen in parallel in 100 towns at once. So that we say, okay, if 20 towns are being sorted out because too small, not enough customers, too expensive to dig, that we still have enough in the pipeline to, at the end, be able to have 10,000 sockets to install, and not in the end to say, oops, we only have 1,000 sockets where we are able to install.
And I think on this scale, it's really shows how business analysis can be valuable for the
Yeah,
business. Because on
that's true.
this scale, yeah, you should calculate every step. You should,
Yeah,
yeah, even 1 minute per socket gives you 10,000 minutes of economy per day, and it's
exactly. Yeah,
becomes huge.
yeah.
Yeah.
Another big thing is, as you see in the second bullet point, we are something like, yeah, sometimes I call it a contact management system.
It's a
Because
big CRM, yeah.
CRM, yeah. Um, uh, we actually have a lot of contacts with customers, of course, about 40 million customers, but also with about 10 million landlords. And we need to know which customer stays in which house, who is the landlord of this house, who is the contact person in this house, because sometimes we have landlords which are big housing companies. So it's not a landlord which is sitting in the house and awaits us, but
Hmm.
there's something like, okay, it's a big company who owns this and 1,000 more houses. If you want to go to this house and drill, there is one guy who you have to call who can open the door for you, right? So we
Yeah,
have to manage
come there, yeah.
contact of this house. We have many construction companies, and in those construction companies, we have um, those guys who do all the appointments, those guys who plan the drilling, those guys who do the drilling. We have partners, we have government agencies, and in particular, these partners here. So we are cooperating with local utility providers, as mentioned before, but also we founded our own off-spins in telecom. So we partnered with capital companies to found our own companies like Glasfaser Plus and Glasfaser Nordwest, which are basically joint ventures of telecom, but they're also using our IT applications. So we actually also have to build a multi-tenant capable system. So it's
Hmm.
one IT system, but there's telecom
There's
in there as tenant, there's another company there as tenant, and so on and so on. So this makes it in particular interesting. And also, as you might know, everyone is having those devices these days, right?
Yeah.
Um,
Unfortunately, it's really complicated to live without them.
yeah. So everyone who is outside and working for us, so outside on the street or outside on the customer, has a tablet and has our own mobile application. For instance, the mobile application to do the exploration with the customer, so to make pictures, where to drill, where not to drill, where it is dangerous because there's water in the wall or so, and where the
Hmm.
customer can sign then. We have mobile applications which show our customers or our installation guys how to connect the fibers and the street cabinets. We have mobile application to install the network termination in the basement and to install the socket in the living room, and also smartphone applications for the customers then to activate their product. When they use their router, they just have to scan a QR code and scan the socket, and then
Hmm.
magically everything works. Yeah, so a multi-contact, multi-stakeholders
Yeah.
application, multi, and all this with a
Yeah.
large scale.
It's really huge. Yeah, take into account that it's actually works as one system. Everything is connected, everything is integrated, and yeah, and to be
Yeah,
able to just to finalize the just to connect the customer, you need to do huge, yeah, amount of tasks before, and
yeah,
all this should be, yeah, working. So it's I can imagine it's yeah, it's really interesting project, I would say.
yeah. And Alexander, of course, I don't want to spoil everything today because, as you mentioned, there will be a keynote, but I brought the next slide here with me so that you see how certain things are done. So in the keynote speech, I will go a bit more into detail, like what was our approach from business analysis, like which solution is the best for which business problem. And I brought the hype solution with me here because AI is currently hyping like mad, right? Everyone does AI. Actually, we use AI in the very first step of the project. So as you see here on the left side, we have our TCAR, and this TCAR basically does this plain image, as you know from your photo camera, like plain image to front and to all other directions. It also does a 360-degree photo image and infrared image, and it does this point cloud. And maybe with the resolution, it's a bit hard to see, but this point cloud is actually the result of a LiDAR scan, which is up to some millimeters correct, which we use for measurement. So the pictures we use to for our planners to see. There's trees, there's other thing, and this point cloud is used for exact measurements later on from the back office. And as you see on the left bottom side, there are certain surfaces here. And as you might imagine, if you want to put a cable into the ground, there are cheap surfaces to open and there are expensive surfaces to open. So cheap is, of course, the left lower one, grass. You can dig into grass, you can put it down, and a week after this, everything's green again. So easy peasy, right? On the left side, everything is cheap. So there is grass, tar, and this is concrete streets. So this is damn easy to fix. On the right side, those are the expensive ones. This one where your mouse is currently is the most expensive you can imagine. It's handcrafted ancient plaster.
Yeah. I believe that it's the most complicated just to put it back together. Yeah.
Exactly. You have to number on the stones, open it, and then put it exactly in this way, and that looks like this. So if we can, we avoid to dig there.
I understand it.
Yeah. And then there is cheap plaster, which is easy like industrial plaster. Then this is, of course, a bit more expensive than concrete or tar, but still it's manual work to put it back. So this is all expensive. So what our AI does, it takes this images and the point cloud and the knowledge, what is expensive and what is cheap, and puts it together into the surface data, and then creates this potential trenches. So it checks, okay, based on this data, potentially the best way is to dig on those blue lines and to cross the street on those red lines. So if you want to change the street side. Even this is not really enough. Therefore, we have airborne. So we have planes who are doing then pictures from above and also point clouds from above, which we use to get all the buildings data that you can't really get from a car which is passing by, so that you see where you have big amount of vegetation, where you have water, where you have just impervious surface, so all sealed with concrete or so. And this is all combined into our potential trenches here. And there even I learned, or we trained our artificial intelligence to even know the tree types. This was particularly interesting. And there I noted, okay, I was so long in IT, but the business side always surprises me. They told me, and it's true, there are different trees. So trees which have roots which go straight down to the earth, and roots which are growing like
horizontally.
this, horizontally. And if you have trees with roots like this, it's dangerous to dig because you hurt the root and then the tree dies. So please avoid those, or keep a larger radius, a larger protection radius. For trees which have roots which go vertically down, you can dig, let's say, 10 centimeters besides it, no big problem. So even this data goes into our AI to see
Mm-hmm.
where we shall dig and not. Because what we also have, we have complaints from the cities like, hey, you digged here and now we have water in the street, or 10 trees died, or whatever.
And it was
So
my favorite tree, yeah, from the mayor's favorite tree, yeah. And now, what we can do?
yeah, exactly. And of course, you want to avoid this. So this is something which we don't want to have and which we want to avoid from the first point where we start
So,
to define those trenches. Yeah.
yeah, I should say that it's one of the most useful applications of AI. Yeah, because
Mm.
actually I think you can do with the AI and combining all this data much better planning than you would do it by manually. Yeah, by people,
Yeah,
because it's really complicated to do this, to process this all amount of data. Yeah, manually.
that is true. Yeah. And although our AI takes hours or days to calculate a city,
Mm-hmm.
it's much, 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 much more faster than we did it earlier on with
Mm-hmm.
human knowledge. I mean, with human intelligence, right? Because there, a poor human, really has to go through every street pictures and check and dig and so. And the AI, of course, it burns a lot of CPU cycles and energy and memory, but it just runs a few days, and then we have the result ready, which shows at least a very good potential plan of the area.
Yeah. You can just go on and check that everything is correct. Yeah, just but again, you have a draft. You
Yeah,
can go on, yeah, with the draft, and I think without business rules, yeah, that comes before for as a basis of all these calculations, it would be really complicated, yeah, to set up to make this AI to provide these results.
indeed. Yeah.
Yeah,
Now,
so
as a little appetizer, because if I look at the clock, we could talk for hours, right?
easy, yeah, because it's real life application, and when you have
Yeah,
such complicated complex project, and it's really interesting to understand how it works and see, yeah,
yeah.
because
So we could talk for hours, but even guys like us, we have to go to bed at some point of time, right? So the title of my keynote speech is not artificial intelligence, it's rules and decision making. And you may wonder now, where the hell did Thomas hide the rules and decision making in this whole thing? And basically, this is a kind of appetizer for our keynote speech. So I was introducing this area journey up front and this customer journey that you see at the basement. And what we unveiled so far is, okay, for this T-car technology, we are using 2D pictures, 3D pictures, and LiDAR scans. And of course, a vast amount of data, so terabytes of geodata and picture data and geospatial data. And we used specially trained artificial intelligence to do our potential tracks and our potential structure planning in this data here. I also unveiled a bit earlier on that we use augmented reality applications for those guys to do the location approval. So they place basically street cabinets in 3D into this augmented reality that we scanned earlier on to then do pictures, videos for getting approval for those locations. We are using the ironing device to to make the map straight.
yeah,
Yeah,
it's great. Yeah, an example. Yeah,
yeah, and on those other bullet points here, we use different methods and technologies to solve this business problem. And in my keynote speech, I would like to also shortly talk about this area journey, but then show you how we used rules and decision making to make a very fast plan of the network. Because what we also saw at Telekom is although we have such a big pipeline and such a big preparation here, unless we check every house up front and check all the details up front, we don't have all the correct data. So it happened on a quite fair amount that we come to a house at this point and said, ooh, it's not having 10 units, it's having 12 units because the roof got extended with apartments, right? And in this case, we need to instantly react and replan. And this is basically also, I was talking about the scale, Alexander, right?
Yeah.
It's not a thing that we can say, okay, installation guy, go back, come tomorrow again to the customer. So no, it needs to happen with a snip of a finger that the IT system is reacting and redoing what we planned and all those things earlier on. Yeah, and this is what I would like to share then at the keynote speech.
Yeah. I really, I can't wait to listen to this because it's again it's really a great example of practical use of these decision making systems, and it provides a lot of value on this scale.
Yeah.
So it helps to save a lot of money and meet customer expectations. And
It's
again, it's really area of business analysis. So it meets, perfectly meets all our expectations as customers of conference. So hope we'll see you all at the conference. So it will be on May 15. And Thomas will be speaking as a keynote speaker in the morning of the conference. So please go to the website, buy your tickets, and don't miss this interesting session because there will be a lot of insights and practical examples how you can use the decision-making systems, decision support system. Yeah.
Decision making, rule making,
managing. So Thomas, thank you very much. It was really interesting, and even I couldn't imagine that it's so complicated. Actually, if it will be possible, I would really just like to have an excursion. We tour around just to see how it works. Because for me, it's sometimes unimaginable just to understanding the complexity. It's just really huge. And I think should be really interesting to work with such system and see it's in real life. It's working.
It is. So looking forward to see you all, guys.
Thank you very much, and see you at the conference. Bye everyone, and
bye
we'll stop our recording.